Hi, chemistry friends. We are going to take some notes on molecular compounds. That would be naming, formula writing, and properties. We're going to cover all three in this video. And so you'll want to make sure you have your periodic table, valence list, line paper, and writing utensil. So if you need to pause a video for those things, go ahead and do that, and then unpause the video when you're ready. For this video, if you need to pause the video to write things down, please do that, but I'm not going to spend a whole lot of time just letting you write stuff down. So with this, we're going to start with properties of molecular compounds. So molecular compounds can be solids, liquids, or gases at room temperature. They do not conduct electricity. The primary building block is a neutral molecule. Electrons are held tightly to each core, meaning that the electrons cannot move from one molecule to another, which is why molecular compounds do not conduct electricity. And we kind of started to bring this up a little bit when we learned about electricity back in Unit 4, but just to reiterate that electrons have to be able to move between molecules in order to conduct electricity. They also have low melting points and low boiling points. So when it comes to naming molecular compounds, you are going to be able to recognize molecular compounds because they're made of two nonmetals. And so you'll have to remember, based on your periodic table, that the nonmetals are in the top right-hand corner of your periodic table. And we'll show, like I'll pull out the periodic table in just a second and we can go through that. But when you name them, you want to make sure that the first word is the name of the element from the periodic table, and you write it exactly as you find it on the periodic table. The second word is has the IDE ending. So you're going to take off essentially the last syllable of the word or the element, and you're going to change the ending to IDE. We use prefixes, and the prefixes are down here on the bottom to indicate how many of each element there are. And again, this makes way more sense when we actually get to it, so hang in for just a second. Realize that if it's di, tri, ena, we would drop the vowel at the end of the prefix if the element also begins with a vowel. So we'll practice this because it makes way more sense when we actually get to practice it. But realize that these are rules for naming molecular compounds. I would highly suggest making sure you have all of this in your notes, including the prefixes, so that way you have good notes to study from for later. I am going to switch over and do this on paper because it's kind of nice to see it on paper too. Okay, so here is my printed slide. We're going to practice doing a couple molecular naming compounds. So what I do want to point out is on your valence list, on the bottom of your list, it says non-metallic compounds, non-metallic meaning molecular compounds. All of the prefixes are listed on the bottom of your valence list, meaning that you don't have to memorize them, but you do have to be able to use them. Being able to use this is so crucial, and knowing how to use it appropriately. So realize that you don't have to memorize those prefixes. They are here for you. So that's really, really important to know. And then you'll still want to make sure that you have your periodic table out because we need to be able to look up the names and the spellings of our elements. And realize that when we're talking metallic, we're talking they should be up in this top right-hand corner up here for them to be non-metal. So pretty much draw a line here, and then everything up in that corner is where you're going to have your two non-metals, meaning it's a molecular compound and you use these naming rules. So let's start with the first one. P2O5, and so the first thing I like to do is look and make sure that I have two nonmetals. So P is here and O is here. So they're both in the top right hand corner, meaning that they're both nonmetals. So I'm going to use my naming rules, which means I'm going to write the first element, P, exactly as I find it on the periodic table. So it's phosphorus. So I'm going to go ahead and write that down. And then the second element, I have to change the ending to IDE. So oxygen is going to become oxide. And I'm going to leave some space here because I need to put prefixes on my elements to tell me how many there are. So P2, 2, And again, if I look at my prefix list here, 2 is di. So I'm going to go ahead and put diphosphorus. And then O is going to be, I have O5, so 5 down here is penta. Oh, sorry, got to get it on the screen. Penta is 5, or 5 is penta. So I'm going to put penta oxide. So you don't have to worry about anything with charges. You don't have to worry about making neutral compounds. You don't have to worry about Roman numerals. You just get to worry about making sure that you're using prefixes. And remember that we don't use mono on the first element, but otherwise everything always gets a prefix. So CO. So when I find CO on my periodic table, so C is here and O is here. And so they're both in the top right-hand corner of my periodic table, meaning that they're both non-metals. So I'm going to use molecular naming rules. And so the first element, I get to write exactly as I find it on the periodic table. So I'm going to go ahead and just label that one as carbon. And we'll get to it in just a minute. And then the second element, remember, we're going to change the ending to IDE. So it's not oxygen, but it's going to be oxide. But because we're using molecular compounds, because we have 2 nonmetals, we need to make sure that we use prefixes. So I'm going to go ahead and turn to my valence list for my prefixes here. So C, there is only 1, but you cannot put mono on the first element. So it just stays carbon. O here, I only have 1, so I'm going to use mono. So I have carbon monoxide, which makes sense because you've heard the term carbon monoxide before, but you have never called it monocarbon monoxide. It's carbon monoxide. So that makes really great sense. So that's really nice. Okay, let's do the next one together because it's really good to get a couple practice rounds in. So SCl, and I know that, so if I find S and Cl here, they're both in the top right-hand corner of my periodic table, which means that they are both nonmetals. And because they are both nonmetals, I'm going to use molecular naming rules for this, which means I'm going to use prefixes. So the first element, which is S, I'm going to write, so S is sulfur, and I'm going to write it exactly as I find it on the periodic table. And then Cl, I'm going to change the ending for that second element. So it's chlorine, but remember we're going to change the ending, so it's going to be chloride. And then because both of them were nonmetals, I need to use prefixes to indicate how many there are. So for the S, there's only 1 because there's no subscript afterwards. However, 1 is mono, and we don't put mono on the first element. So sulfur is just going to stay sulfur. Cl, on the other hand, needs a prefix. There are 3 of them because of my subscript 3. So 3 is tri. So I'm going to go ahead and put trichloride. So my answer here is sulfur trichloride. Okay, so I want you to pause the video and I want you to try D on your own and then unpause the video when you're done to check your work. Okay, so on the next one, what you did for D, hopefully we got dinitrogen tetroxide. For it, you realized, hopefully, that nitrogen and oxygen are both in the top right-hand corner of the periodic table, meaning that they're both non-metals, so that's why we were going to use molecular naming rules for that. Nitrogen, I got to write exactly as I found it on the periodic table. Oxygen, I had to change to oxide. And then I used prefixes, so 2 is di, and 4 is tetra. And that's kind of weird, but I think about Tetra, the game Tetris, everything has 4 blocks. You can check it out if you're a gamer. So Tetra technically has an A at the end, but I take the A off because of the fact that O is oxygen started with a vowel as well. So this is how we name molecular compounds. And it's really not too bad. If you think this is easy though, we're going to show you how to do the writing the molecular formula for molecular compounds, or writing the formula for molecular compounds in just a couple examples. Because if you can do the other way, this way is probably the easiest thing you will do for naming all the time. So for these, tetraphosphorus decoxide. So when I do this, when I name this one, I look at, okay, well, right here, it tells me that it's phosphorus. And the prefixes are what tells me that it's molecular, and the prefixes tell me I don't have to do anything with charges. This is the one time you don't have to make sure you have a neutral compound because there are prefixes there. The prefixes tell me it's molecular, and the prefixes are just amazing because then I just don't have to do as much. So phosphorus, when I find phosphorus on my periodic table, it's the letter P. Tetra in front of it, tetra is 4, so that means that I'm going to put a 4 there. Decaoxide, well, remember oxide, we can't find oxide on the periodic table, but we could find oxygen because the ending would change. And again, the last letter, A, had to come off because oxygen also starts with a vowel. Deca is 10. So P4O10. This is the best part of writing formulas, realizing when you have molecular compounds and you seriously just get to use prefixes on them. So selenium hexasulfide. So selenium, I see a hexa, which means I see a prefix, and the prefix is there and tells me that I don't have to worry about charges. I just get to worry about what the prefixes are to tell me how many of everything there is. So that tells me that it's a molecular formula. So selenium, when I find it on the periodic table, is right here, and it's the letters Se. And there's no prefix in front of selenium. So remember, if there's no prefix, that means that there would be 1. Because the other one has a prefix, that's why I'm looking for prefixes to tell me how many there are. So sulfide would be what I would be looking for the next part, for my next element. And I can't find a sulfide on my periodic table, but I can find a sulfur. And remember, we would change that ending, so it's going to be sulfur. And so hexa here, if I don't remember how many sides a hexagon has, because that's pretty nice there, hexa is 6. So I'm going to go ahead and write a 6 there. So the prefixes, if there's a prefix on one of those, then that's, or both of them, that's a huge hint that you are looking to use the prefixes telling you how many there are, and you don't have to do anything with charges. So I'd like you to try C on your own by pausing the video, writing it down, and then unpause the video when you're done so we can check your work. So for this last one, we found nitrogen, and we know that that's the letter N. First thing I realized was that there were 2 prefixes, and the prefixes told me I don't have to do anything with charges. So that's really, really nice. So the nitrogen is N, and the di in front of it tells me that there are 2 of them. And oxide is oxygen, so I know I'm using the letter O, capital O. And the tri in front of it tells me that there are 3 of them. So if you have any questions on writing molecular formulas, writing molecular names, or any of the properties of molecular compounds, please, please, please make sure you find your teacher and ask them questions. This is the end of our video. Thank you.